Good morning, everyone. So today we will be discussing the solution of test, definite integration and area under the curve. So in question number 1, we have been given integration of f of t dt from 0 to x is equals to x plus integration of t square f t dt. If we differentiate this with respect to x, we got f of x. This is simple. We got f of x equals to differentiation of x, which is 1, plus differentiation of this 1 into f of 1 into differentiation of 1, that is 0, minus x square f of x into differentiation of x, that is 1. So from here we got take this side, we got f of x equals to 1 upon 1 plus x square. All right. Now we have to find integration of fx minus 1 to 1. F of x is even function. F of x is even function. So we can write minus a to a fx dx is equals to 0 to a fx dx 2 times. So this is 2 0 to 1 dx upon 1 plus x square. We already know that minus a to a fx dx equals to 2 times 0 to a fx dx if f is even, if f of x is even. This property we used here. This is simple integration. Dx upon 1 plus x square is tan inverse x, 2 tan inverse x. Put the limit 0 to 1. 2 times pi by 4. Tan inverse 1 is pi by 4 minus tan inverse 0 is 0. So this is answer is pi by 2. So option C is correct answer. Move on to the next question. Question number 2. This is simple problem of limit as a sum. If we take n square common, it will be like 1 upon r by n whole square minus 1. This n square will be common and it will get cancelled out. 1 upon n remains here. So 1 upon n summation 1 upon r by n whole square minus 1. R varies from 2n plus 1 to 3n. Now we can convert this into integration form. 1 by n is replaced as dx. Limit is replaced as integration. R by n is replaced as x. So integration 1 upon x square minus 1 dx. Now we can find out the limits. When r by n, r upon n is equals to x. All right, r upon n is equals to x. So when r is equal to n plus 1 upon n divided by n, n approaches infinity. N approaches infinity. We can find out limit r upon n equals to x. R is, the value of r is 2n plus 1 upon n. Limit n approaches infinity. This approaches 2. So lower limit is 2. All right, lower limit is 2. Similarly, when r was 3n, r upon n will be 3. This upper limit is 3. So we got lower limit 2, upper limit 3. Just integrate this. This is dx upon x square minus a square form. Dx upon x square minus a square. This is simple integration. 1 upon 2a ln x minus a upon x plus a. So the answer will be 1 upon 2 ln x minus 1 upon x plus 1. Put the limit from 2 to 3. We will simply get our answer 1 upon 2 ln 2 by 4 minus ln 1 by 3. Further solving it, this is reduced to 1 upon 2 ln 3 by 2, that is equals to ln root 3 by 2. So option B is the correct answer. Move on to the next question. Question number 3. This is dx upon 1 plus x to the power pi by 2. So if we see that first analyze this graph. First analyze this graph. This is the graph of 1 upon 1 plus x square in interval 0 to 1. This is the graph of 1 upon 1 plus x to the power pi by 2. This power is approximately 1.5 something. And this is the graph of 1 upon 1 plus x. 1 upon 1 plus x. When we integrate this, we get this area. We get this area. So we have to find the area subtended by this graph. This will be this area. So we can clearly see from the graph that the area subtended by the required graph I will be lesser than this and greater than this, lesser than this and greater than this. All right. So we can say the area required will be greater than this dx upon 1 plus x 0 to 1 and lesser than dx upon 1 plus x square 0 to 1. So I will be, we can find out the limit of I. The integration of 1 upon 1 plus x is ln x. Sorry. 1 upon 1 plus x is ln 1 plus x and put the limits. Put the limits, that is ln 2 minus ln 1. So ln 2 is the answer. And here tan inverse x, put the limit from 0 to 1. The answer is pi by 4. So the value of I lies between ln 2 to pi by 4. So we can check our option. Option A is the correct answer. Option A is the correct answer. Move on to the next question. Question number 4. In question number 4, we have been given, we have to find the value of I, which is x square sine x at 8 plus sine square x. All right. Now we will first write sine square x as 1 minus cos square x. So the denominator will be 9 minus cos square x. Now we will use integration by parts. Consider x square as first function and this whole function as second function. Use integration by parts. First into differentiation of second. First into integration of second minus integration differentiation of first into integration of second. All right. So we have to find the integration of this, which can be easily find out. Suppose cos x is t, sin x dx is dt. So this will become dt upon 3 square minus a square. dt upon 3 square minus t square, which we used in the previous question. Integration of dx upon a square minus x square formula. All right. So integration of this will be minus ln 3 plus cos x upon 3 minus cos x upon 6. Simply here, just put cos x equals to t minus sin x dx will be dt and again dt upon a square minus t square. This is the integration. Minus integration of differentiation of second function, that is 2x into integration again this is the integration along with minus sign, put it here. All right. So now we can simply put the value of limit in this. This will be equals to minus 2 pi square ln 2 by 3 minus 0 plus here this is 1 by 3, this is 1 by 3, and suppose this integration is I1, we will calculate I1 separately. So this is I1. All right. Now if we use the King's property we all know very well. King's property क्या है? a to b fx dx equals to f of a plus b minus x a to b dx. This is King's property. We all know very well. This is the most important property in definite integration. So suppose we applied King's property, replace x with 2 pi minus x. 2 pi minus x ln 3 plus cos 2 pi minus x cos x 3 minus cos x. Alright. Now suppose this is 1 and this is 2. Both are equal. Add both 1 and 2. We will get 2i1 equals to 2 pi. 2i1 equals to 2 pi. It will get cancelled out. Integration ln 3 plus cos x upon 3 minus cos x. Now I1 is I1 is now this in property. From here we will use the property number Queen's property, which is called 0 to 2a fx dx is equals to 2 times 0 to a fx dx. All right, when a is the period of the function. When a is the period of the function. So again, we can write this is I1 is equals to 2 times pi 0 to pi ln 3 plus cos x upon 3 minus cos x. Now I1 is this. Now use again the King's property. Now again use King's property here and replace x with pi minus x. I1 equals to 2 pi ln 3 plus cos pi minus x minus 3 cos pi minus x. Now add both I1 plus I2, this will be 0. I1 plus I2 will be 0, so I1 is also 0. So the final answer, put the value of I1 here, the answer we got is minus 2 pi square by 3 ln 2 plus 0. So this is, I compare this with the given equation. We got L equals to 2, M3, K2, L plus M plus K is 7. I hope it is clear to everyone. Now we move on to the next question. That is question number 5. This question is again from the concept of limit as a sum, integration as a limit of sum. In this, first we write it in general form. Summation form. It can be written as limit n approaches infinity summation r to the power 99 upon n to the power 100. R varies from 1 to n. R varies from 1 to n. Now take n common, so this is 1 by n, and write r by n to the power 99 summation. Now we know how to replace. R by n is replaced as x, 1 by n is replaced as dx, and summation is replaced as integration. All right, this is dx, this is summation, and this is x. So now we have a simple integration. The problem has been reduced to this simple integration, that is x to the power 99 dx 0 to 1. Differentiate, integrate this x to the power 100 by 100. Put the values of limit, that is 1 upon 100 is the final answer. Option B is the correct answer. Now we move on to the next question, that is question number 6. In this, we have been given integration minus 1 to 3 modulus of x minus 1 plus greatest integer x dx. All right. So we can break this integration minus 1 to 2 modulus of x minus 2 plus 2 to 3 modulus of x minus 2, because x minus 2 will change its sign at x equals to 2. All right. And then minus 1 to 3 greatest integer x dx. In the interval minus 1 to 2, modulus of x minus 2 will be 2 minus x dx plus 2 to into interval 2 to 3. It is a positive quantity, so it will open as x minus 2 dx. Now we will open, now we will break down this greatest integer function. In interval minus 1 to 0, this is minus 1 dx. All right. In interval 0 to 1, when the value of x is 0 to 1, this is 0 dx. When the value of x is 1 to 2, it is 1 dx. When the value of x is 2 to 3, it is 2 dx. All right. Now just simply integrate. Integration of 2 is 2x. X is x square by 2. Put the value of limit 2 to minus 1 to 2. Again, the integration of x is x square by 2 minus integration of 2 is 2x. Put the value of limit 2 to 3. Now here minus 1. The integration of minus 1 is minus x. minus x, put the value of limit, it is minus 1. This is 0 only. And when this integration is x, this integration is x, and the value of limit 2 minus 1, 1 only, and the value of this is 2. All right, this here, this here, and here. Now this gets cancelled out. Now here we get, if we further solve these are very simple and trivial problem now. The sum is equals to 7. So option A is the correct answer. Now we move on to the next question. Question number 7. This is a good question. You must practice these kind of questions. Students generally find difficulty in these questions, and also these are frequently asked in JEE exam, and these are the type of questions which decides your rank. These are the kind of questions which most of the students face difficulty with. So you must focus on these. So suppose let I is equals to this. I is equals to integration 0 to 1 x f double dash 2x dx. All right. If we integrate this using integration by parts, x is a first function and f double dash is a second function. So first into integration of second. Integration of this is f dash 2x upon 2. Put the limit 0 to 1 minus integration differentiation of first, integration differentiation of x is 1, into integration of second, that is f dash 2x upon 2 dx. All right, now we can solve this very easily. Put the value 1 into f dash 2 upon 2 minus 0 minus integration of this is again f of 2x divided by 4. Now put the limits 0 to 1. This is f dash 2 upon 2, and here f of 2 minus f of 0 upon 4. All the values f dash 2, f of 2, f of 0 is given to us. Just put the values 5 by 2 minus 3 minus 1 upon 4. This is equals to 2. Option C is the right answer. Move on to the next question, question number 8. In this, we have been given the integration. If we put e to the power x upon 3 equals to t, e to the power x upon 3 dx will be dt. All right. Now substitute these in the integration, in the given integration. This is 1 minus cos 2t, and in the numerator e to the power x dx is 3 dt, is 3 dt. So e to the power x dx is 3 dt. All right. So this is 3 dt upon 1 minus cos 2t. We will change the values. We will change the limits. When x was ln pi by 2, when x was ln pi by 2, we will put ln pi by 2 here. E to the power ln pi by 2 is pi by 2. Pi by 2 by 3 is pi by 6. Pi by 2 by 3. So the value of t is pi by 6. The lower limit is pi by 6. When the value of x was log pi, we will write e to the power ln pi divided by 3 is t. So this is pi, this is pi, and this is 3. So pi by 3 is the upper limit. Now this is a very simple problem of integration. 1 minus cos 2t can be written as 2 sin square t. Now 3 by 2 integration cosec square t dt. We all know the integration of cosec square t, that is minus cot t. So minus 3 by 2 cot t is the integration. Put the values of limit from pi by 6 to pi by 3. Minus 3 by 2, 1 by root 3 minus root 3. So the final answer is root 3. Option A is the correct answer. Now the next question, that is question number 9. In this, we have been given a we have been given a, and we have to find the value of this. Let this is equals to I is e to the power minus t minus a minus 1 dt. We have to find the value of this in terms of a. In terms of a, if we rewrite this, just take minus 1 common from the denominator, and we can rewrite this 1 plus a minus t dt. All right. Now here substitute a minus t equals to z. So dt will be minus dz. dt will be minus dz. These two values substitute in the integration. This will be e to the power z minus a dz upon 1 plus z. Now change the limits. Change the limits. When t was a minus 1, when t was a minus 1, z was 1. So the lower limit is 1. When t was a, z was 0. So upper limit is 0. If we further integrate this, this can be written as e to the power minus a can be taken as common, and we switch the limits. So there is an additional sign, there is an additional negative sign because we switch the limit 0 to 1. So minus e to the power minus a integration e to the power z upon 1 plus z. Can you see? This is a which is given in the question. This is a which is given in the question. So we can say minus e to the power minus a into a is the final answer. Option number B. Now move on to the next question, that is question number 10. In this, we have to find the value of integration I. Let's say this is I is equals to integration greatest integer x square minus greatest integer x whole square. All right. Now we will break this. First we will deal with this part. First we will deal with this. We will break this. This will be broken in. This will can be broken into 1 to root 2 1 dx, root 2 to root 3, because this will be discontinuous when this will become integer, and x square will become integer at 1, root 2, root 3, 2, and so on. All right. So first we are dealing with this part. This from 1 in 1 to root 2 interval, this is 1 dx. Then root 2 to root 3, this is 2 dx. And then root 3 to 2, this is 3 dx. All right. And now we will deal with this minus in interval 1 to 2, greatest integer of x will be 1 only, and it's square dx. All right. Now this is simple problem. Just integrate 1, that is x, put the value of limit root 2 minus 1. Here 2 times root 3 minus root 2 plus 3 root 2 minus root 3 minus 2 minus 1. Simply solving this, we are getting 4 minus root 2 minus root 3. This is given in option number C. So option C is our correct answer for question number 10. Now we move on to question number 11. Question number 11. It is given that dt upon t root t square minus 1 is equals to pi by 2. Okay, we have to find the value of x. So this is the direct integration. Tell me, this is the direct integration of sec inverse t, right? So sec inverse t root 2 to x equals to pi by 2. Now put the limits. Sec inverse x minus sec inverse root 2 is equals to pi by 2. Sec inverse x, this is pi by 4, is equals to pi by 4 plus pi by 2. So this is equals to 3 pi by 4. Sec inverse x equals to 3 pi by 4, x equals to sec 3 pi by 4, which is equals to minus root 2. This is a simple problem. See, in this question, there were concept of integration as well as inverse trigonometric function. And JEE is most likely to ask such questions which include more than one concept. These kind of questions are JEE's favorite. So please focus on the questions which can be integrated, which can be coupled with multiple topics. All right. Now we move on to question number 12. In this, I is equals to this is given. All right. We have to find the value of I. See, this is ln of ln x 2 times. All right. 2 times ln of ln x, let's say it is t. Then ln of ln x will be t by 2. Ln x will be, take e this side, e to the power t by 2. X will be e to the power root e to the power t, this, and which is written here. So can we say that if this is function f2x, this is function f2x, if this is function f2x, then this is f inverse x. So f1 and f2 are inverse of each other. F1 and f2 are two functions which are inverse of each other. All right. So f1 and f2 are inverse of each other. So in these kind of questions, if f and f are inverse of each other, the integration is simply the product of upper limits minus the product of lower limits. Minus the product of lower limits. So the upper limits will be, the product of upper limits will be 1 into e root e minus the product of lower limit is 0. So the final answer is this. This is important question. You can mark for yourself. This is important. Okay, so answer is option number B. Now the next question, that is question number 13. In this, we have to find the value of given definite integral from -1 to 1. Let's say cos inverse x, we put cos inverse x equals to theta to reduce this complicated expression. So cos inverse x is theta, cos theta equals to x, all right. Then sin theta equals to 1 minus x square. This we already know. Now the equation has been reduced to tan inverse sine of theta, tan inverse sine theta plus cot inverse cos pi by 2 minus theta. Sine inverse x can be written as, see, this is cos inverse x. Sine inverse x can be written as pi by 2 minus cos inverse x. And this is theta. So pi by 2 minus theta. So here we have written cos of sine inverse x means pi by 2 minus theta. Now we have tan inverse sine theta plus cot inverse sine theta, which is given as pi by 2. Which is given as pi by 2. Suppose this is t, this was phi, this is suppose phi, and we know that tan inverse phi plus cot inverse phi is always equals to pi by 2, is always equals to pi by 2. So this is phi, this is also phi, so tan inverse phi plus cot inverse phi is always equals to pi by 2. So this whole value is reduced to pi by 2. Now we have to integrate pi by 2 from the interval -1 to 1. That is pi by 2 into x. Put the limits. Pi by 2 into 2, that is pi. Option D is the correct answer. Now we move on to next question, that is question number 14. In this question, we have to find the limit x approaches 0, integration of tan inverse t whole square upon integration of sine root t. See, when x tending to 0, this is 0 and limit is 0 to 0. So this part is tending to 0. And again here this is also 0. The limit is ranging from 0 to 0. This integration is also tending to 0. So this is 0 by 0 form. 0 by 0 indeterminate form. In this we can use L'Hopital rule. In this we can use L'Hopital rule. We can differentiate both. We can differentiate numerator separately and denominator separately. So in differentiation of numerator will be tan inverse x square whole square into differentiation of x square, that is 2x, divided by differentiation of denominator. So that is sine of x to the root x to the power 4 into differentiation of x to the power 4, that is 4x cube, that is 4x cube. Now x is cancelled out with this, this is x square. So this 2 is cancelled out with 4, 2 is cancelled out with 4, that is 2. So here we have tan inverse x square whole square sine x square into x square. Now we can easily solve. Divide by x square into x square. This is 1. Now this part, tan inverse x square upon x square 1. Tan inverse x square upon x square 1. So this is also 1. This is also 1. So the value of limit is 1 by 2. I hope it is clear to everyone. See, this sine inverse x square divided by x square. Sine 0 by 0 is 1, multiplying by x square. Now this tan inverse x square upon x square, 2 times, 2 times. This is also 1. So this is 1 by 2 is the final answer, option D. Now move on to next question, that is question number 15. In this, we have to find the value of A. A is given as this. Alright. Suppose we write this A square. This is A. Suppose this is A. So this is A square plus 1 by A square minus 2A 1 by A. This can be written as A minus 1 by A whole square, which is written here. Which is written here. And yeah, this is under root. So power is half. So this gets cancelled out. So this whole expression is reduced into A minus 1 by A. So this is A and this is 1 by A. Alright. Consider x plus x minus 1 as A, and this is automatically 1 upon A. And here this is 2 times A into 1 by A. So this part is A minus 1 upon A. Now we have to integrate this x plus 1. Now further solve this. Cross multiply. This is x plus 1 whole square. X square plus 1 plus 2x minus x minus 1 whole square. Now this is cancelled out. This. Now we have integration of 4x upon x square minus 1. See, this is an odd function. This is an odd function because this is even, this is odd. So this overall function is odd function. Minus a to a fx dx is equals to 0 when fx is odd function, when fx is odd function. So this is simply 0. The value of a is 0. So the greatest integer of a by 4 is also 0. Answer is B. Now move on to next question, that is question number 16. We have to find the area bounded by the curve y is equals to 3 minus x this, and by the curve this. First we will define the modulus function. When x is less than 3, the function is 3 minus x, that is equals to x. And when x is greater than equals to 3, 3 minus x will be opened with a negative sign, with an extra negative sign. So it will be 3 minus x minus 3. This will be 6 minus x. Similarly, we will define the function second one. For x greater than minus 1, x greater than minus 1, this is positive. So it will open as it is 6 upon x plus 1. When x is less than equal to minus 1, this is a negative quantity, so it will open up with extra negative sign, minus 6 upon x plus 1. Now we will draw both these curves. Both these curves drawn, we will draw these. See, this part, this is 3. For x less than 3, y is equal to x is the function. For x greater than 3, y is equals to 6 minus x is the function. This is graph number 1. Alright. For x greater than minus 1, the graph is y is equals to 6 upon x plus 1. This is y is equals to 6 upon x plus 1. Now we have to find the area bounded by these two curves. So this is our required area. This is our required area. How can we find it? See, in this interval, we will find this point of intersection, which we can easily find out. We can easily find out y is equals to x, y is equals to 6 upon x plus 1. Put value of y as x, put value of y is x. This is equals to x, so x into x plus 1 equal to 6. We can simply get x is equals to 2 is the answer. So this point of intersection, x is 2, y is 2. So this point is 2 comma 2. Now we have to find this area. First we will integrate the upper function. Upper function is this part x, and the lower function is 6 upon x plus 1. So x minus 6 upon x plus 1 in interval 2 to 3. All right. Now from here onwards, on the right hand side, the upper function is y is equals to 6 minus x. So integration 6 minus x upper function minus lower function, that is 6 upon x plus 1. 6 upon x plus 1. Now integrate 3 to 5. This is also a point of intersection. We can find out y is equals to 6 minus x. Y is equals to 6 upon x plus 1 equals to 6 minus x. Solve these two. X equals to 5 is the answer. We will get the point of intersection. So now we will integrate this area from x3 to x5. We will get this area. Now integrate x is x square by 2 minus 6 ln x plus 1. Put the value of limit from 2 to 3. Now here 6x minus x square by 2 minus 6 ln x plus 1, limits 3 to 5. Now this is the put the value 2 to 3, that is 3 square minus 2 square. 3 square minus 2 square, that is 5 by 2 minus 6 ln 4 by 3. 4 by 3. Now 6x is 5 minus 3, 2 minus 1 by 2 minus 5 square 25 minus 3 square 9 divided by 2 minus 6 ln 6 by 4. 6 by 4. Now if we solve this, this is 5 by 2. We will solve, we will get the answer 13 by 2 minus 6 ln 2. Option C is the correct answer. Now question number 17. Now question number 17. If the area bounded by the curve. So first we will draw the given curve. This is simple polynomial. Its roots we can easily see. This is equal to 0. Roots are 1, 2 and 3. So these are the roots 1, 2 and 3. So we can draw this curve. This is a very simple curve. This is the infinite, up to infinite, and this will go here and infinite. Now we have to find the area. This area, this area and this area. This is our required area. So area can be find out as 0 to 3 modulus of y dx. So y dx, all right, first we will find y is equals to x minus 1, x minus 2, x minus 3. This is x cube minus 6x square plus 11x minus 6. If you multiply these three, you will get x cube minus 6x square plus 11x minus 6. So the area will be magnitude of y. Magnitude of y. So this is y dx. All right, from 0 to 3. So this is given in option number B. So this is quite easy question. Now moving on to question number 18. Question number 18. The area between the curve y is equals to 2x to the power 4 minus x square and y is equals to x square 2x square minus 1. First we will solve these two equations together. First we will solve these two and draw the graph. See, we will solve these two and draw the graph. All right. So this is when take x square common. This is x square 2x square minus 1. put equals to 0, and we will find the roots of this equation, that is 0 and plus minus 1 by root 2. So roots are 0, 1 by root 2, minus 1 by root 2. Now we will find a stationary point. Differentiate this, that will be 8x cube minus 2x. Take 2x common, 4x square minus 1 equals to 0. So stationary points are 0, plus minus half. These are the points where y dash will be 0. Y dash will be 0. So these are minus half, 0, and plus half. These are the stationary points. We know the roots, we know the stationary points. We can draw the graph now. We can draw the graph now. So this is the graph. At x approaches minus infinity, function will be plus infinity. At minus half, y dash will be 0. Now this and this is the graph. We can easily draw the graph now. All right. Now this graph is symmetric about y-axis. All right, and we have to find this area. We have to find this area. So this area is equal to this area. If we find this one alone, if we find this area, we can just double the area. So area is 2 times 0 to half, 0 to half by dx, 0 to half by dx. All right. So y is equals to y dx. Now 0 to half, 2x4 minus x square, 2x4 minus x square. Just integrate this and finally we will take the modulus. All right. So 2x4 integration is 2 to the power x5 upon 5 minus x cube by 3. Put the values of limit 0 to half and we will get our final answer. And take modulus here and take whatever the value is, take the modulus. So this will be 7 upon 120. So option B is the correct answer. Now moving on to the next question, question number 19. Area enclosed by the curves. X square plus y square equal to 1. This is the equation of circle. Suppose this white line, this is the circle of radius 1, and mod y equals to 1 minus x square. This is modulus y equals to 1 minus x square. See, this will be y is equals to 1 minus x square. So y is equals to 1 minus x square is in such way like this. This is a downward parabola. And minus y equals to 1 minus x square. This is upward parabola. This is upward parabola. So we have to find this area, this blue region we have to find. All right, this is the blue region. And this is symmetric graph. So if we find the area of one region, one blue region, we can just multiply it with 4. We can just multiply it with 4. So this area is simply, if we find this area, all right, and 4 times will be this area. And if we subtract these 4 from the whole area of circle, then we will get the desired area. All right. So the area of the whole circle is pi r square, radius is 1. So area is pi minus 4 times this area alone, this red one. And this can be find out by integrating this from 0 to 1. From integrating y is equals to 1 minus x square from 0 to 1, we will get this area. And by multiplying it with 4, we will get this. All right. So 4 times 1 minus x square dx, 0 to 1, pi minus 4, integration of 1 is x, integration of x square is x cubed by 3. Put the value of limits from 0 to 1. We got pi minus 4 times 2 by 3 minus 0. So the final answer is 3 pi by 3 minus 3 pi minus 8 by 3. So it matches with none of the options. So option D is the correct answer. Option D is the correct answer. Now moving on to the next question, question number 20. We have to find, first we will draw y is equals to e to the power x. This is y is equals to e to the power x. This is y is equals to ln x. This is y is equals to ln x. And we already know that these two graphs are inverse of each other and symmetry. All the inverse graphs are symmetric along y is equals to x line. These two graphs are symmetric along y equals to x line and these two are inverse of each other. Now x equal to 0, x equals to 0, y is equals to 0. So x equals to 0 is this line, y is equals to 0 is this line, x equals to 2 is this line, and y is equals to 2 is this line. So we have to find ultimately this yellow part, this region. How do we find this area? Area is, suppose I find this area and this area. These two are symmetric. See, these two functions are symmetric. So these area are also equal. These area are also equal. So if we find 4 and the area of this whole figure is, this is a rectangle, this is actually a square, 2 into 2. This whole area is 4. If I subtract these two area, 4 minus 2a, we will get the required area, and 4 minus 2a, and a is one such area, either this one or this one. So we can easily found this area. This area can be written as ln x integration 1 to 2. So 4 minus 2 times integration of ln x dx 1 to 2. 4 minus 2, we all know integration of ln x dx by integrating by parts. This is a very famous integration, x ln x minus x. Put the value of limits from 1 to 2. Now 4 minus 2 times 2 ln 2 minus 1. So this is 6 minus 4 ln 2. I think option A is the correct answer. Option A is the correct answer. So that's it with the part 1. In the next discussion, we will be discussing the part 2 of the definite area integration and area under the curve. I hope it is clear to everyone. All right. Thank you guys.